So it's my pleasure to welcome Martijn Kersloot. I hope my Dutch pronunciation is not so terrible.
Perfectly fine.
Thank you. So Martijn is an assistant professor at the Amsterdam University Medical Center. And I'm really happy to introduce you, Martijn. So the floor is yours. If you can share your screen.
Yes, I hope you can all see this this presentation now.
Yes, thank you.
Great. All right, yes, thank you very much for this opportunity to present to you the FAIR principles. So this indeed is one of the first webinars in the webinar series, and we'll probably, well, set the stage for the rest of the webinars in this presentation as well. So let's dive into the FAIR principles. But maybe before I do that, maybe take one step back and look at the way that you do research. So probably if you do research, you do research according to a few steps. And these steps can be kind of summarized in the research data life cycle. It's kind of a life cycle describing all the phases of a research project with the associated data management tasks. They basically describe how you handle the data that you collect in your research project. Because once you start your research project, you plan and design the project, you collect and capture data, you collaborate and analyze the data that you've gathered, and then hopefully once you've analyzed your data, you got some results, and then you store the data that you have collected somewhere, and then afterwards you write a nice paper about it, publish hopefully the paper, and share the results in that paper, and maybe even share your data so others can then discover, reuse, and cite your work. And these last two steps, so sharing and publishing results and data, and discovering and reusing and citing data and papers, are really the drivers of how we practice medicine and in nowadays, and really make sure that we progress in science. So based on the research that we've done in the past, we think of new research projects, and then this cycle starts again. But what we also see is that approximately 80% of the data that we currently collect in scientific research cannot be reused for other purposes than it was specifically collected for. And that's mostly because the data management in research projects really focus on using data for a single project, maybe because you only have budget to manage your data for your project, and afterwards you kind of deposit it somewhere, and then, you don't really think about the reuse of the project. Also, maybe because data are unstructured, so you don't really describe your data well, so others don't really know what your data is about. And I'm not sure about you, but I recently opened a data set that I created 5 or 10 years ago, and I did not really know what every column meant in my data set because I kind of lacked the documentation around that. So I'm guilty of that myself as well. But this has quite an impact. So they're not having reusable data, just reuseless data, data that is unstructured, brings many challenges. So it's challenging to combine data from various sources. So if you want to combine your data with data from someone else, that's hard because your data, and maybe even their data, is not well described. So you don't really know if you can combine your data sets. But also if you want to do some advanced analytics on your data, for example, using AI, using machine learning techniques on your data, you should really know what the data mean. And that's really where the structure of the data comes in. And there's also quite a big financial aspect on not having reusable data. So 5 years ago, the European Commission asked PwC, a consulting company, to calculate how much money is wasted every year on data not being reusable. And they estimated that at 10 billion euros per year, because we spend time, effort, and funding on lots of research. And after the research projects, the data and the results often end up on the shelf. So if we could reuse the data, that would, of course, be really beneficial. And that's also what the authors of the FAIR principles thought. So in 2016, these principles were published. There are 15 guiding principles. So good to note that they're guiding principles, they're not rules of law. And they describe scientific data management and data stewardship. So how you should manage and handle the data that you collect. and also data about your data, metadata, and the infrastructure that you store that data and your metadata on. To summarize a bit what they do, they kind of describe what you should do with the data and the metadata that you collect and the infrastructure you store that on. But they're guiding, so they do not really describe how you should do that. So they, well, it's not really a checklist that you go through. It's more of a direction that you're steered towards. And this webinar also not really, doesn't really focus on the how yet. The rest of the webinars in the series will do. This webinar will mostly focus on the what. So what should you do with your data and your metadata? And I think for most of us, well, we already knew that FAIR was an acronym. It stands for Findable, Accessible, Interoperable, and Reusable Data and Metadata, both for us as humans, as researchers, but mostly also for machines, for computers. And making your data and your metadata findable then means that your data is described, identified, and registered in a way that's unambiguous, so that well, everyone really knows what your data and your metadata are about, specifically computers. We'll touch upon that in a bit. Accessibility means that your data and your metadata are accessible through clearly described access procedures, and that the metadata that you collect, so the data about your data describing the data sets that you have, are always accessible even when your data is not accessible anymore. Interoperability means that you express and structure your data according to common published standards based in your domain. And reusability means that the characteristics and the provenance, so for example, the contact information about your data sets are well described with clear conditions of who can use your data under what circumstances. And we'll touch upon all of these principles in a bit. But before I do that, maybe look at some of the misconceptions around the principles. So I think even a couple of years after they published the FAIR principles, maybe even a year, the authors of the principles came up with a new paper because lots of people gave their own well, understanding of what the FAIR principles meant. So they published another paper describing really that FAIR is not a standard, as I said. It doesn't well, give you a checklist of things to work through. It's only they're only guiding principles. And most importantly, also FAIR does not mean open. So if you want to make your data more findable, more accessible, interoperable, and reusable for others, doesn't mean that they have to access it over the web, that they have to publish it out in the open. It can also be that your data set is perfectly well described, but then it's only available upon request, or maybe not even upon request and only FAIR for yourself. And lastly, FAIR is not just basically around about humans being able to find, access, interoperate, and reuse data, but really FAIR at its core is making sure that computers can do that. And if computers can do that, then later on we can find a way for humans, for us researchers to understand that. But if we can describe our data and our metadata in such in a detailed way that the computer can understand it, then we should be good for humans, for researchers as well. So I've been talking around FAIR data and making data machine readable, but why do we need that then? So I said, well, we collect lots of data. You've seen this research data lifecycle, and over the years, this kind of body of knowledge that we are building together with all these researchers and the amount of available data, so the data we store, is growing exponentially. And we involve lots of participants in the research that we do. So in clinical trials, for example, lots of people contribute to that and contribute to data. So based on all of this data that we have, we really want to maximize the knowledge that we can get from that data. But you can also understand if we have lots of data that's growing exponentially, the amount of data, then we are not really able to operate at the scope, at the scale, and the speed required to do so. And that's where computers can help us. So instead of us researchers finding, accessing, interoperating, and reusing data in our own small little cubicles, we can ask the help of computers to do that at a much larger scale. And therefore, we need this machine-readable metadata. And what are the benefits then of these machine-readable data? Well, first of all, I think I mentioned this already. If you really describe your data set well, it allows for unambiguous interpretation and analysis. So if you see your data set 5 years From now, you still know what your data set is about, but also a computer can really understand what your data set is about if you've described that to the core. And if you've done it and others have done it as well, so if you have described your data sets well and other people have described their data sets in such a similar way, we can perform distributed analyses. So if everyone describes their data, for example, in a research project in a similar way, we can send the analysis algorithm from a computer to the data. So the data doesn't then have to leave the premises of a hospital or a research site. So if everyone structures the data the same, we can use the same analysis algorithm for that. This is one of the other benefits of FAIR data. And if you really describe your data well, and others have done so as well, that really allows you to combine different types of data because you know what the data really mean. It's easier to combine different data sources together. And finally, because it's well described, it can then also be processed automatically by a computer in, of course, much more efficient and scalable manner. And I think Marco asked me to add a superhero here because I think the people in this webinar are superheroes, people doing research on rare diseases or people living with a rare disease. So by doing all this, we really boost the performance of reusing data and then for the benefit of people doing, for people living with a rare disease. And especially in the rare disease field, it's important to describe your data well because the data is scarce. If data can stay at the source and it's well described, then we can do this distributed analysis to have a much larger data set to draw conclusions on. And I already described what the FAIR acronym meant, but maybe let's dive in a bit deeper and see what all the individual principles mean. So let's start with findability. As I said before, data set should be described, well described and indexed in a way that's unambiguous so that you really know what the data set is about. So first of all, this findability contains four different principles. The data and the metadata must be assigned a unique identifier, kind of a tag, so that you know where to find the data and the metadata. Similar to if you publish a paper and you get a DOI, we would like that for a data set as well. So you have one way to retrieve the data and the metadata about the data set. We should add extensive metadata, so data about the data to the data set to make sure that people can kind of filter down on all of the data sets that are available on the web to find your data set. And lastly, the data and the metadata should be included in a searchable resource. So for example, a repository where you can do this filtering. Moving on to accessibility. So datasets should be accessible with a clearly defined access procedure. So again, not open access specifically, but a clearly described procedure. And the metadata should always be there, even if the data is not there yet. So here we have two main principles. So the data and the metadata should be retrievable using a protocol that's standardized. So it should not be some custom script that you've wrote to get access to the data, but a standardized protocol like the internet, where you can retrieve data, which is open and free and universally implementable. So again, not some arbitrary standard, but something that others can use as well in your domain. And that protocol would then allow for authentication and authorization. So we should be able to see if someone has access to the data for a specific purpose. So again, that doesn't mean open access. So you can really define the access procedures for that. And lastly, if the data is not available anymore, the metadata should still be there. So we know that someone did research about a specific topic, or we know who we can contact to get access to that data. Then interoperability. Data and metadata are then expressed and structured using standards that are common for the domain that you work in. And kind of giving the example that I mentioned at the beginning, me looking back at the data set that I collected 5 or 10 years ago, if I would have used a well-described kind of summary or documentation around my data set, I would probably now be able to still reuse the data that I've collected, but that's still challenging. So we should really make sure that we represent the knowledge that we have in the data and the metadata using some vocabulary, so standardized ways of expressing your data. And we'll touch upon that in future webinars. So for example, in the medical field, we have vocabularies like SLOMAT or LOINC, which are medical dictionaries that assign terms to be readable for humans, but also for computers. That's really what interoperability focuses on, so that we can really understand what the data is about, but definitely also that the computer can do so as well. And lastly, that the data and the metadata should include references to other data metadata. So for example, if you have reused data from another researcher, then you should maybe add a link to that. If you have carried out your research at a specific site, then maybe you can add a link to that as well. So we really well describe the data set that we have. And then reusability. And some of these principles kind of looks like the findability, the principles, but they are really focused on making sure that you know if and how you can reuse the data that you find. So the characteristics of the data and the provenance should be well described according to standards in the domain, and really making sure that it's clear if and how you can reuse data later on. So they should be described with relevant attributes to assess the appropriateness for reuse. We've seen that in the F principles, the findability principles as well, that we really have to describe our data sets well. But for reusability, we really focus on if you found the data set, can someone tell if the data set that they found, if that's something that they would be interested in reusing. And secondly, the data and the metadata should include a clear data usage license, so who can use the data under what circumstances, and some provenance, so who can we contact if we have questions about this data and who created this data. And then lastly, the data and the metadata should really meet domain relevant community standards. So again, not some arbitrary standard that you've developed yourself, but something that everyone in your domain can understand. So that was quite a lot of information about these principles, and I always, when I try to explain it, also really goes over my head rather quickly. So what I'm trying to do now is to link these principles back to the research data lifecycle. So maybe give you some ideas where you can already start applying the FAIR principles in the work that you do. And then, of course, in future webinars, we'll focus a bit more on how you can do that in depth. But if you plan and design your research project, you can already start planning for complying to these FAIR principles from the beginning. So most people do that by developing a data management plan. In this data management plan, you really describe how you should handle your data, how you're going to describe your data later on, how you're going to make it available, or if you're going to make it available for others for reuse. So that's the first step. If you collect and capture the data, you could really make sure that the data is collected using standards and tools that facilitate sharing later on. So making sure that the data that you collect also is well described for others later on. And of course, important is to make sure that you ask consent for participants to use your data in future research. So if you want to make sure that you want to share your data later on, make it reusable for others, then we need consent from participants for that. If you're going to analyze your data afterwards, make sure that you process your data using formats and vocabularies that are widely understood. So no CSV files with questionable column names, but try to link that to domain-specific standards. And we'll go over that in future webinars, how to do that. And then also make sure that your analysis scripts are made available as well. Not really part of the FAIR principles, but it's really adds to the reusability of your data. If you've done that, then probably after the analysis phase, you want to store your data and store your data in a repository from your institute, for example. And most of these repositories will give you a persistent identifier, like a DOI, that you can use later on to cite your data or to share the metadata about your data. And make sure that you add metadata to the data. So don't come up with a title yourself, which is relatively short, that only you can understand right now, but make sure that you add some metadata that really well describe your data set. And if you've done so, you can make your data set and your metadata available via this repository, and make sure that you then also add appropriate licensing to really specify if people can reuse your data and your metadata and under which circumstances. And hopefully then your data sets are then discoverable if they're published in a repository and usable for secondary research. And then it's, it would be really nice if you can collaborate with others to integrate the data that you've collected with existing resources, so you can make more impact with the data that you've collected in your research project. So to summarize, so making data fair really increases the value of the data and reduces waste and inefficiencies. And by making sure that we make data fair, making data machine readable, we also make sure that we can perform distributed analyses. And for example, in the case of rare disease data, this is really beneficial because we have smaller data sets. But if we can combine multiple data sets into a larger one, we can answer more research questions. And important to take home, don't really verify your data or your metadata after the fact, after you've done your research project, but really try to integrate all of these steps to make your data more fair in the way that you do research. And well, I've told you a bit more about the what, but the next webinars will really focus on the how. So that's the end of my presentation. Are there any questions?
Martijn, are there any questions? So the plan for this second part is to have a panel discussion. So Martijn will be joined by Marco Ros and Claudio Carta, who are here with us. So feel free to unmute yourself and ask any questions or post anything in the chat.
Maybe also to add that right next to me is Cesar, so he's kind of in the panel as well.
Marco needed some
Yes.
emotional support here.
Yeah.
Well, also good to have an extra panelist knowledgeable on the topic, right?
Yes. So I will start then. So which do you think are the barriers in order to implement these principles? Because my impression, at least, is that they exist like for 8 years now, but I'm not sure how much they are implemented fully, at least. So do you believe that there are specific barriers that make their implementation difficult?
Shall I have a first go? And
Sure.
maybe it's nice to put my second camera on as well, and I'm pleased. Yeah, and I'm also looking at people. So one of the maybe to do this from a positive point of view is that the thing we've seen to be successful, and when we do successful projects, and by the way, I don't think anyone in the world has done fully fair. So I think all the people who are the originators of the FAIR principles would say the same thing. So that also means be cautious for when there's parties who say, oh, we can do fully fair with you, because that's really a high bar to achieve. And it's good to take it as an incremental process where you become fair and fair, or you take a certain part that you make fair and later you do more. That's all perfectly fine. But to come back to the question, so what we've seen when verification collaborations are successful is when, and there are many factors, but one that I've seen is very important. If there is in the collaboration between people who have done verification before, who have expertise there, if they're on the people who are generating or collecting new data, if there's someone in that team who's also committed to doing that and not afraid of also learning the technical parts of it, to really be a collaborator in the verification process. And I've also done projects where such a person is missing, where, for instance, for us as verification people, our only line of communication is with a group leader. Then I've seen those almost always fail, or at least not be as successful as we'd hoped for. So it really requires this collaboration and an investment, also a time investment of a person on the data generating or data collecting side. So maybe that's one aspect that I would put forward as a success factor. And if it's not there, it's a huge barrier. I try to put that now in lobbying, for instance, if there are new funding calls, that funders will make this a requirement that you appoint someone in that role. And maybe the others have other barriers, because there are many barriers. So I can imagine that others would highlight a different barrier in the process. There's also so maybe, yeah. So Petrus, you'll be chairing.
Yes. So I don't know if anyone wants to comment on this before I give the floor to others to ask questions.
I can maybe add 2 more barriers that I had to think of before we indeed go to the next people. But I think it's also because it requires quite some technical investment to make your data more fair, I think, as Mark also said. So it's good that you can appoint someone on a project to do so. But of course, I think the goal would be to make it as easy as possible for someone to do so. So right now, I think one of the barriers is still that you need to have some sort of technical background, or at least have someone with technical background on your team to help you make your data more fair. And then we're lacking tools and maybe also education for people to do that themselves. But I think it's, well, we're getting there step by step. But right now we need, well, some more technical expertise from others to help with that.
And Petros, yes, let me say something. For sure, yes, sustainability, you need to foresee this, the data management plan for sure in your project, this verification process, to have different skill in your staff for the different aspect of the verification. This is another point that you need to take into account. And probably I ask the support of Marco and Martin, but following also our experience in the Bring Your Own Data, also start to verify, to look at your data strictly on your question, on your main question, research question that you would like to answer, which data you are collecting, and start to verify strictly the data. Not try to verify everything from the beginning. Try to start with few variants, see the challenge that you can meet during the process, and then you enlarge the plan. So this could be also a suggestion.
Thank you. Thank you very much. So we have 2 questions. Kyriaki, would you like to unmute and ask your question?
Yeah, great talk. Thanks for the insights. I know you said you're only on what it is rather than how to do it, but my question is, how do you foresee these for already collected data? Is that feasible?
Yeah, so I think, I really made a point of doing this when you start your project, but indeed, of course, you have lots of projects that are already running. But even then, you can really make sure that the data that you collect is more fair. So that doesn't really change the verification process that much. But it means that you need to spend more time on looking at your data that you've collected and modeling that data according to something that can be understood by a computer at the end of your project, which costs a bit more, quite a bit more time in comparison to doing that from the start of the project.
Yeah, I guess the main issue would be in the case that you cannot really share. I mean, you can make them fair, you can make them accessible and everything harmonized and all. I mean, we do that anyway, but the sharing principle is a bit more of an issue if you if you don't have it in place from the beginning. So the consents are not for sharing the data in general. So I'm not sure, you think there's a way around that?
Yeah, and I think, well, fair is not really about making sure that you share your data or that it's openly available, of course. But what we've seen at projects that we conduct here is that we either ask patients again to give consent. So if they have participated in a trial, if they really want to consent again for the reuse of their data. or it just helps you as a researcher if you have made your data more fair, because if you want to reuse the data for yourself for a second time for the same purpose as you collected it for, then it would also already help you. But yeah, you don't have to be 100% fair, of course, if that's yeah.
Okay, great, thanks.
I see Marco talking, but I don't hear Marco
maybe
yet.
I can add something to this. And I think you already pointed it out, so maybe I can just reiterate that when you do it in hindsight, then it's maybe it's fair to say that it's really, maybe we should calculate this at some point, that it's really substantially more, can be substantially more work, and or substantially less efficient. And one of the reasons I think there is when you are still collecting the data or doing the design of the project that is going to generate or collect data, is that you have all the expertise available. And one of the things that slows us down, we've seen that in our rare disease project, is we need to make a model for common data elements. And we basically didn't have a direct connection with the people who defined these common data elements. And the definitions were really very, very small, right? There was not a lot of information to go on for us to understand what would be the right ontology term for this common data element. So when you're still starting, then you have all the expertise available, you can be quicker, and you can address it immediately. For consent is maybe an example that you're discussing that, right? When you start collecting or generating data, you must, right, to discuss this with the people who are providing the information. And then the fair step would be try to capture this in a structured way, what the result is, what people have consented to, make sure that it doesn't go lost, give it an identifier. And then one step further, try to make that something we are working on to make that machine readable as well. But it's already a step. Even having the document with the consent still available with an identifier that is persistent, that is already a big step. In a lot of the projects, these things are unfindable, and then the whole data set becomes unusable. So that's already a step you can take. And these are all things that is easier to do when at the moment that you're doing it. It's just a little bit of extra overhead for the verification, also doing it for machines. But it's really more efficient when you do it right then, in the moment.
Thank you. So are there any other questions? So just a follow-up question from me about what Kyriaki asked about existing projects. So let's say that we have several projects that we've done in the past, and we would like to evaluate how fair our data are. So how close we are to that dream, let's say, of full verification. What is the best approach to follow for that? I know that the question is more about how rather than what, but maybe we can have an idea of how we can evaluate how much work it is to verify existing data sets.
Ooh, that's a tough one to evaluate how much work it will be. So we have a rule of thumb that at least I use, that it's and that I also use in project proposals or when we're discussing what should be there. And that's basically that we have identified over the years that the core group of people you need for doing a verification project is that you need a person who is an expert of the software that is being used, a person who's familiar with the data that is being generated, and also a sort of data worker, and that there's a verification expert, and ideally, especially when it's a bit larger, is a fair project manager who knows how to get people together at the right time, etc. But especially these three parties, that they need an equal amount of time. And we calculate that for a moderately sized data set as 2 person months per party. So you have to 6 person months in total. Net time, right? So that can be spread over a longer period, but that's then the sort of the minimum. Another rule of thumb that I know the original founder of the FAIR Principles, Barend Mons, uses is for projects to have 5% set aside for the data management. That's another rule of thumb. But maybe it's also fair to say that in doing projects like HEMA-FAIR, we can actually maybe improve on our estimates, because I'm quite sure that they're wrong in practice, but also that we can find out what are the important factors in why they may sometimes become more or less in other cases. What is the ideal setup? So we're still learning. I think that's also fair to say.
Plus, I think still
Thank
after
you.
the fact, you don't want to maybe verify everything that you have. So maybe you've collected some variables you want really certain that no one is going to reuse them ever. You can decide on not verifying them, of course. So at least making sure that you have a minimal data set that's available in a fair manner.
Yeah. There's, by the way, one additional barrier that I think also communities like this can also help with. It's actually a bit of my frustration with my own community. So especially I'm frustrated in the realm of the interoperability part, which is I find the most interesting, but it's also the most challenging. And over the maybe even decades, we have seen very good tools appear and disappear. They go in disarray, in decay. And when you Google for a good tool, you often find an enormous amount of papers about good tools, but the actual list of tools that are still functional, that is quite low. One of my theories is that because it's often semantic web tools, that semantic web is actually too easy. So it's too easy for people to make a new tool, rather than to continue with an existing tool or make it sustainable. But one of my aims is also we actually and also Barend started the whole institute to see if we can improve on that situation, that we get more professional tools, sustainable tools, and reusable tools. So also, for instance, that we're now in this project can use REDCap, a version of REDCap that is fair and that we can sustain as a fair tool. We are working with Martijn as well for Castor, if that can be a sustainably tool for making certain sets of data fair, then that would also lower the cost substantially, because then for data sets that are similar or very similar to existing data sets for which this tool has been developed, then the price would be much lower. And we need communities to emphasize and tell people, or maybe even see how it can be invested in that certain tools remain and stay good tools.
So a sustainability
Good point.
plan
Sustainability.
Maybe also
Sorry.
Petros
Sorry.
institutes like yours and ours could perhaps. I also like to lobby for things like that in our own institute. That institute like ours could be custodians of some of the tools. That we commit ourselves to keep some of these tools alive, even though they're used elsewhere by others.
So, Marco, we go back to this. Foresee a sustainability plan for also the data management and the verification process and all the data that you are gathering and again start from your main research question and then eventually enlarge, taking care of the budget, taking care of the person. And
So we have a question from Stella.
Yes, I think my question is a bit more on the how again. It was really interesting the what, but what I wanted to connect a little bit the what and the how is between the sharing and the ontologies. For example, we have the data, we use a common standardized ontology. Do we store the data using that identifier? For example, let's say Stella is this code. So are we using the code also for the sharing, for the storing? I'm a little bit confused on the implementation, actually.
Sounds like a question for Martijn and maybe even Cesar.
Yeah, I'm not really sure if I understood your question, Stella. Sorry, but if you mean if you store your data, if you do that in a similar way as that you would share that same data set?
Yes. How I'm using the code, the ontology, both to describe the data and for sharing the data.
Yeah, Cesar, feel free to add to me, of course, but at least what I see in practice is sometimes that you describe your data in a bit more in detail with these ontology concepts, so that you would use maybe for sharing. So you really well describe the data that you have, so people know how every element in your data set relates to one another. But if you're doing your own analysis on the data, if you're using R, for example, well, R can't really work well with those data structures, at least not that I've seen. So then you would still have a different data structure. So in my understanding, you still have two different ways of storing your data, maybe a bit more the traditional way for doing your analysis, but then also the really well described FAIR way that you can also share with others. But Cesar, I'm not sure if you have other thoughts on that.
Yes, exactly that.
I understand that Stella's question is a bit on how do you use the ontology codes in your data? Is that correct to say?
Yeah, yes, that's exactly from raw data to
Ontologized data.
Yeah.
Yeah, that requires a bit of a technical answer because it really depends on the file formats you're using, and how you're exposing your data, even the querying of the data. For example, if you store in a SQL database or in RDF or in CSV, there are different ways of doing so. And I guess that this will be a workshop, a webinar per se, right?
Yeah.
I think there's one scheduled around ontologies and how to use them. So that's
And maybe I can add my 2 cents as well. I've been thinking about maybe an analogy of what we often aim for when we do FAIR. That's also about clarity. So imagine that you have your data collection, and that maybe one of your people have created that, and you need to pass it on to a new employee or maybe to a student. You would probably write down, if it's a let's imagine that it's a data set with a table with lots of columns and rows. You would probably write a document that explains how to interpret what each column is, what each row is, and how these things relate to one another. You would write a document for that to pass on to the successor of your of an employee who created it. Now, the thing with FAIR is that you basically do something very similar, and that important is that document is next to your data set. It's next to it. You don't do anything to your data set. It's just a document that describes your data set so that someone else will be able to use and manage it. What we do in FAIR is that we also do such a document, but then we look at global standards of doing this description. So we're not describing it for just the successor in your own organization. We're describing it for the world and for computers to be able to understand what is your data set about, how can we use it. But it's also similar in that document can be next to that machine readable document is also sitting next to your original data set. And what we then can technically do with such a description is that we can convert, and sometimes we do, sometimes we don't. You can convert your original data set completely in terms of that machine readable description. So then they kind of become one and the same thing. It basically becomes a knowledge base, your data set. And sometimes we do, sometimes we don't, because you can also do these things on the fly, but that's a more technical thing. But it's a lot about having this description and then having this description for the world, for machines.
Okay, thank you.
Thank you very much. So before I give the floor to Coralia, just to mention that we are conducting a couple of surveys as part of HIMA FAIR. So one of them is your understanding about FAIR principles. So we kind of cheated today because we already introduced the FAIR principles, but we will ask you what you understand if you complete the survey. It's in the chat. So please complete the survey, and you will hear from us with additional links about the different surveys we do. So Coralia. We cannot hear you. No, we cannot hear you. Your microphone is not connected, maybe.
Now? You can hear me now?
Yes.
Thank
Yes.
you. Sorry for this. So I'm new to this verification field. So I enjoyed this lecture, Martin, this introductory topic on FAIR principles. And I will go with the flow of the lecture series and ask something on the what, not how. And maybe it has been addressed by Marco. But so cost is a barrier based on these interesting discussions. I'm wondering how institutions can incentivize researchers to devote time and effort in verifying their data. How can small labs, what, let's say, practical steps they can take to ensure that they have verified data, and how we can maintain these efforts like long-term sustainability, you said, if we are a small lab, sharing the data, let's say, to maybe this is not, maybe it's not a good question, but help me understand this better. So data is shared, let's say, on a server. Is it accessible to other people? Can other people help continue the verification process? What about ownership of the data if it's open, let's say, on an open server? So maybe these couple of issues, just to clarify them for people that are not really familiar of how this, let's say, verification process works. And thank you.
Yeah, that's a lot to unpack there, I think. But maybe the first step could be to describe the data that you have. So maybe not really do the entire verification pipeline of every single data point that you have, but make sure that you deposit some metadata about your data sets in a repository, so people know that they can contact you to find out those data sets. So even
if they
don't
also assist with the verification of the data, and what's the benefit from them if they want to assist? For example, Marcos said that you maintain the tools even though you don't use them. Other people can use them. So how does that work? Or maybe, yeah.
Maybe on that one, I can just an example that maybe can be an outcome of our collaboration in HIMA FAIR is so we Peter shared the RedCap instance that you're using. So I can imagine that at the end of the project, we'll have a version of RedCap that can do verification for hematology related data sets, or at least one set of data elements that we could do with that tool. So we can keep that. We can then keep that instance of RedCap to ourselves, or we say, we make that open source. Anyone who wants to use perhaps a plugin or something for verification, if you have similar data, here it is. You can use it. It's we will fix some bugs if there are minor bugs, right? Not major things, because then you won't have funding for it. But something like that. That could be how you can help the community. Or that could be another thing that you actually look at business models that could also be interesting to see. But this could be one example of where you do something back to the community. to a larger community. So that's one of the things that were unpacked. Martijn, maybe you have other things you want to address.
And we also need to, let's say, we need to persuade the institutions to provide the means to encourage people to verify data. And I think this is also an aspect of the HIMAFAIR project. We have this management structure, the research office, everything that I think it's not just this lecture, what are FAIR principles. I think institutions need to also understand the importance of this and help researchers proceed with this activity.
Yeah, and this may be the biggest challenge, the change management. So this is where culture needs to change, and I think this is one step or 2 steps forward, 1 step back, and going back and forth, and slowly we see progress. I do think we see progress. Interestingly enough, at the same time as we're doing this webinar, there's a session here in our own hospital by someone from one of the Dutch funding organizations, the one that's doing rare disease funding as well, but doing funding in the health domain. And they had one project where the funding organization took part of the responsibility of the verification themselves. So that was a very interesting paradigm project on how funders can actually play an active role in helping this cultural change. In the end, it's then not so costly because it's just people learning getting some new expertise. And then if you start doing this from scratch, it actually, it's not so costly anymore if you have the expertise in-house. It's also part of our HIMAFAIR objective that the Thing Institute in Cyprus will have some of the expertise in-house, and then the more institutes have that expertise, it can spread.
Yes, and I think it's very important to demonstrate and make the organizations understand that by verifying the data, you actually have more opportunities than before, because a fair data set is much more valuable, and it will open new opportunities in the future for even funding and new collaborations. Okay, so we are 5 minutes before the end, so I don't know if there are any final questions or remarks from the panel before we close. No? So we had more than 40 people attending, so I think it was a very successful session. I would like to thank all of you for attending, and the panel for the insights they provided. So for one last time, I would like to urge you to complete the survey that was posted in the chat. And our next lecture for this series is in January next year, and it will be about biomedical ontologies. So you will receive invitations a few weeks before that. So once again, thanks for joining, and we will be in touch.